Hi everyone, welcome to my channel Tech Tutorials 2K21. So today I'm going to explain a very important concept in compiler design, that is a structure of compiler or different phases of the compiler. So simply a compiler is a translator or a program which is going to convert a high level language to machine understandable language. So it will take the source code in high level language as an input and it produces the output as a machine language. So in mean of that, it is going to pass in different phases and it will convert high level to machine language. So the compiler is having 6 different phases and each and every phase will take input from its previous phase. So simply we can say the output of the previous phase will be acted as an input to the next phase. So we have 6 phases in the compiler. One is the lexical analyzer, second one is a syntax analyzer, and the third one is a semantic intermediate code generator, code optimizer and code generator. So these are the different phases of the compiler. So now we will see each and every phase. So lexical analyzer is the first phase of the compiler which takes an input as your source code. So now this lexical analyzer will read character by character, means it can read one character at a time and it converts into a meaningful form. See, for example, if I am given an instruction like int a comma b. So this is a computer instruction which I am given in my C programming language. So what your lexical analyzer will do, it will read character by character. Okay. And it will convert into a meaningful lexeme or a token. Okay. So tokens is nothing but it's a small piece of the code. Suppose if I consider this is a code. So now in this code, I can say this is my data type. And these are different identifiers. This is an identifier 1, this is an identifier 2. And I can say these are the variables. A, B are the variables. I have two symbols here. One is a comma and another one is a semicolon. So comma is separator and semicolon is a terminator. So if I take this line of code, what your lexical analyzer will do, it will read character by character and it will convert into a meaningful lexeme or token. So simply after this step, we are getting that these are going to be identified like what we are given in your instruction. Like it can identify this is a data type and these two are the identifiers and these two are the special symbols and one symbol is going to separate, another symbol is going to terminate. So that is going to happen in your lexical analyzer. So now this output which is generated from your lexical analyzer will be given to a syntax analyzer as a input. So we consider this example and we'll try to understand what's happening in each and every phase of the compiler. So here you can see this is an instruction given. So we consider an instruction like position is equals to initial plus rate multiplied with 60. So this is a statement is given for a lexical analyzer. So as we know, the lexical analyzer will read this character by character and it is going to convert into a meaningful form, that is in a form of lexemes and tokens, so that it can identify that in this statement it's having three identifiers. So this is the first identifier and this is the second identifier and this is the third identifier and this will be another identifier of type constant, right? So it will convert like this. So now this output will be given as an input to the syntax analyzer. So what syntax analyzer will do? It is a second phase of the compilation and it will take the output of the lexical analyzer that will be in a form of tokens, and it is going to generate a parse tree. So now you can see this is a parse tree or a syntax tree. So it will check the expression whether it is syntactically correct or wrong. Now you can see this expression. So on my right hand side, I have an expression like initial plus rate, which is multiplied with 60. And after computation of this expression, I'm going to assign this value to another identifier, that is a position. So now it's check in this phase whether this everything which is given from my previous phase, that is a lexical analyzer, is syntactically correct or not by constructing this parse tree. So now you can see a parse tree. So you can construct a parse tree in any of way. Either you can use a top-down parser or the bottom-up parser, and it is going to construct a syntax tree or parse tree. So now this parse tree is given to a semantic analysis as an input, and this is the third phase of the compiler, which checks whether this parse tree will follow the rules of your language or not. So now it will see all the identifiers and the inputs, and it is going to check whether this is semantically correct or wrong. So now you can see here by your expression you can find your initial rate, and these will be of type an integers, whereas this constant value, so it will be in a form of floating point. So what simply it is going to do now, it is going to convert, means the type conversions, if anything is required, that is going to be happen at semantic analysis phase. So the semantic analysis phase is also generate a parse tree, and which we can say it's an annotated parse tree because the values is going to be substituted at each and every level of the node, and that will be given as an input to your intermediate code generator. So now this intermediate code generator will take input from the semantic analysis, and which will be act as an intermediator between your semantic analyzer and code optimizer, and it is going to generate an intermediate code which is in a form of 3 address code. So it is take each and every instruction, and it is going to be converted as an intermediate code. See, for example, here T1, T2, T3, these are the temporary variables. So now you can see the first line of the code is T1, that equals to, now this value is going to be converted from integer to float, and that is going to be assigned to a temporary variable T1. And for T2, this value is going to be multiplied with an identifier 3. So now you can see this constant value is available at T1 variable. So simply we can say T2 is equals to identifier 3, which is going to be multiplied with the temporary variable 1. And after that, this entire result will be available at T2. It's a temporary variable. Again, we can take the identifier 2, and which we are going to add this T2. And now we can store it another temporary variable T3. So simply we can say this is temporary variable T3, which will going to add your second identifier with the temporary variable 32. And then now this entire answer is going to be assigned on a left hand side of the identifier 1. So simply we can say ID1 equals to T3. So in this way it is going to construct an intermediate code for the output generated by your semantic analyzer. So now coming to code optimizer. So it is an optimal phase, so which is used to optimize the code which is generated by the intermediate code generator. So it is try to reduce the code before it is going to convert into a machine understandable language. So here you can see these 4 lines of code is reduced to 2 lines here. Now you can see like this constant value is directly multiplied with an identifier 3, and it is going to assign to one temporary variable, and after that this temporary variable is going to add with an identifier 2, and directly that value is assigned to your identifier 1. So now the code optimizer is using some techniques or an algorithms, and which is used to reduce the code which is generated by an intermediate code generator. And this will be taken as an input to a code generator, and which is going to generate the code for the target machine. So this will be the final state of a compiler, and it takes this optimized code which produces by the code optimizer, and it convert into a machine understandable language. Now you can see here these instructions are converted into a machine understandable language. So simply we can see, so the identifier 3, so this is, and it is going to be loaded into one register, and after that this constant value is going to be multiplied with this register content, and the second identifier and the registered one is going to be it is going to be loaded into a registered one, and the registered one and the registered 2 means the resultant of this multiplication is going to be added with another register, and after computing the result, that is going to be stored in ID 1. So in this way the compiler will convert a high level language to machine understandable language. In mean of that, it is going to use your symbol table and error handling. And we see that when the compiler is going to convert a high level to machine language, and it is also produces an error, it's related to syntax. So for that, it is going to use your symbol table, and it stores those temporary values in a mean of processing, and whenever any syntax error is there, it is going to be handled by this error handler. Thank you.